Section 5.4 deals with definite integrals, and it starts with this definite integral as a limit of sums, and you're more than welcome to read over this part with Riemann sums and how you approximate areas of rectangles and adding those up. So it's basically just how this definite integral comes about, where we have positive and negative values over an interval. The positive values naturally are above the x, negative values below the x. So I am not going to stress anything on that. I'm just going to go right to the definition of a definite integral. We have a lower limit of integration, which is written, the number is written down at the bottom, and an upper limit of integration. And then, of course, the integrand. So this is the integral of a to b of f of x dx. And what that happens is that represents a cumulative sum of areas beneath the graph. Okay, so when we look at this function, this area A below the graph is negative, and the area B above the graph is positive, so that the area from A to B in terms of capital A and B would be negative A plus B. Okay, so looking at some examples. So if I want to know the integral from A to B of this function f of x, so looking at where A and B are, that would just be the area of block A. And since it's below the curve, it would be negative 2.12. Okay, I just copied the example again over here since it's on the second page. From A to C. So if I look at A and where C is, that's going to be the area of A plus the area of B. The area of A is negative 2.12, and the area of B is 11.9. And I add those together, and I get 9.78. From B to C. From B to C is just area B, which is 11.9. And in D, it goes from A to D. So from A to D is the area A plus the area B plus the area C. Area A is going to be negative, area B positive, and area C negative. Adding those up, I get 2.11. Okay, so there is a matched problem with areas A, B, and C. I copied it over onto this page, so complete A, B, and C. Keeping in mind that area A goes from A to 0. Okay, some properties of definite integrals. If our upper and lower limits are the same, then the integral of that is 0. If I go from A to B, and I reverse the order from B to A, so instead of going from left to right, I go from right to left, it negates it. If I have a constant, that can come out in front. An integration of a sum or difference, I can split. And I can write, if I'm writing an integral from A to some number, I can go into an intermediate number and add them together. So let's look at using some properties. Here's some defined integrals. finding from 1 to 3 of 4x squared would be, or 4x cubed would be the same as taking 4 times the integral of 1 to 3 x cubed dx. And that's defined as 20. So this would be 4 times 20. Again, I put the defined values over there, and I'm sorry if this is small. This would be the same as 1 to 3 of x to the third dx minus 2 times 1 to 3 of x dx. So substituting in values, and actually I wasn't paying attention. There is no x, it is a 2x. So let's just go ahead and put that back in there. So 1 to 3 of x to the third is 20 minus 1 to 3. 2x is, excuse me, 8. So this equals 12. This would equal and I'm going to be minus negating because it's upside down. So negating this is negative 20 minus negative 8 equals negative 12. 1 to 4. So 1 to 4 is the same as 1 to 3. Taking the 4 out front. Plus 4, 3 to 4. And so this is going to be 4 times 20 plus 4 times 80 plus 175 is, oops. And I see in the last example, 11 to 11, it's automatically they're the same, so this is going to equal 0. Okay, matched problem 4. There is A. I'll give you a few minutes, a few seconds to look at that. And then B through E. Try to zoom in on that as much as I can for you. And that is it for section